Hello. I think we're live. 12-hour pythonathlon. But one should be done. Well, it's at 2 now. It should be done at like 4 p.m. today. Uh, I'm broadcasting my main stream. I guess it's fine. I guess. Um, Actually, if I remove this, I could broadcast my second monitor, which has the CS50 artificial intelligence with Python video. So I guess it would be better than just staring at a code editor. Which I guess I'll do. Maybe I could do both. No, that'd be stupid. That'd be stupid. I don't know what I'm gonna do. Do we got? I got the flipping.
State S. So let's take a look at an example.
Oh, gosh darn it. Okay, there we go. Now it's over here. I have a text editor over here. Just Python file. This is gonna be a pain. Not quite sure what I want to do. I was trying to learn AI in Python, which gave me the artificial intelligence course from Harvard in Python. But I'd like to make something first, like maybe like a chatbot or something in Python through the terminal. But I don't want to like use ChatGPT because you're not making your own artificial intelligence. You're just making an app that uses the API. It's bullcrap. Can't do that. Like search algorithms is a pretty um, introductory. I hope that's a word. Introductory way to start in machine learning. Um, so I guess I'll start with maybe like an hour course on search algorithms. Well, this is a pro code 4-hour one. I could probably get that done. Um, um, I'm starting up a 12-hour stopwatch. Okay, start. Alright, 12 hours starting now. Yeah, I want to do data structures and algorithm full course with bro code. Oh, this is a Java one. Ooh. Algorithms and data structures. This is a free code camp.
Thank you for calling Capital One.
My team's Gen AI tool helps you answer customer questions.
An important concept and a way of writing out, this time making sure that we give it a
That's
target
a Python one. Stit.
search until you find this value,
It's only 5
because that can
hours.
be interpreted in many ways and further broken down into many more steps. It's not clear. Next, and this one might seem obvious, but algorithms should produce a result. If it didn't, how would we know whether the algorithm works or not? To be able to verify that our algorithm works correctly, we need a result. Now, when using a search algorithm, the The end result can actually be nothing, which indicates that the value wasn't found, but that's perfectly fine. There are several ways to represent nothing in code,
I'm at
and as long as the
1.25
algorithm can
speed.
produce some result,
That's
we can
fine now.
understand its behavior. The last guideline is that the algorithm should actually complete and cannot take an infinite amount of time. If we let John loose in the world's largest library and asked him to find a novel, we have no way of knowing whether he succeeded or not unless he came back to us with a result. Okay, so quick recap. What makes an algorithm and not just something you do? One, it needs to have a clearly defined problem statement, input, and output. When using linear search, the input needs to be just a series of values. But to actually use Brittany's strategy, there's one additional precondition, so to speak. If you think about her strategy, it required that the numbers be sorted in ascending order. This means that where the input for John is just a series of values, to solve the problem, the input to Brittany's algorithm needs to be a sorted series of values. So, clearly defined problem statement, clearly defined input, and clearly defined output. Second, the steps in the algorithm need to be in a very specific order. The steps also need to be distinct. You should not be able to break it down into further subtasks. Next, the algorithm should produce a result. And finally, the algorithm should complete in a finite amount of time. These guidelines not only help us define what an algorithm is, but also helps us verify that the algorithm is correct. Executing the steps in an algorithm for a given input must result in the same output every time. If, in the game I played, the answer was 50 every time, then every single time, John must take 50 turns to find out that the answer is 50. If somehow he takes 50 turns in one round, then 30 the next, then we technically don't have a correct algorithm. Consistent results for the same set of values is how we know that the algorithm is correct. I should stress that we're not going to be designing any algorithms on our own, and we'll start off and spend most of our time learning tried and true algorithms that are known to efficiently solve problems. The reason for talking about what makes for a good algorithm, though, is that the same set of guidelines makes for good algorithmic thinking, which is one of the most important skills we want to cultivate. When we encounter a problem, before rushing in and thinking about solutions, what we want to do
Just
is
forever
work through the
thinking about this third
guidelines.
one.
First, we break down the problem into any possible number of smaller problems where each problem can be clearly defined in terms of an input and an output. Now that we know how to generally define an algorithm, let's talk about what it means to have a good algorithm. An important thing to keep in mind is that there's no one single way to measure whether an algorithm is the right solution because it is all about context. Earlier, we touched on two concepts, correctness and efficiency. Let's define correctness more clearly because before we can evaluate an algorithm on efficiency, we need to ensure its correctness. Before we define our algorithms, we start by defining our problem. In the definition of that problem, we have a clearly defined input satisfying any preconditions and a clearly defined output. An algorithm is deemed correct if on every run of the algorithm against all possible values in the input data, we always get the output we expect. Part of correctness means that for any possible input, the algorithm should always terminate or end. If these two are not true, then our algorithm isn't correct. If you were to pick up an algorithms textbook and look up correctness, you will run into a bunch of mathematical theory. This is because traditionally, algorithm correctness is proved by mathematical induction, which is a form of reasoning used in mathematics to verify that a statement is correct. This approach involves writing what is called a specification and a correctness proof. We won't be going into that in this course. Proof through induction is an important part of designing algorithms, but we're confident that you can understand algorithms, both in terms of how and when to use them, without getting into the math. So if you pick up a textbook and feel daunted, don't worry, I do too, but we can still figure things out without it. All right, so once we have a correct algorithm, we can start to talk about how efficient an algorithm is. Remember that this efficiency ultimately matters because they help us solve problems faster and deliver a better end user experience in a variety of fields. For example, algorithms are used in the
Advertisement.
sequencing of DNA, and more efficient sequencing algorithms allow us to research and understand diseases better and faster. But let's not get ahead of ourselves. We'll start simple by evaluating John's linear search algorithm in terms of its efficiency. First, what do we mean by efficiency? There are two measures of efficiency when it comes to
Dude,
algorithms,
when do we get to the
time and
programming?
space. Sounds really cool and very sci-fi, huh? Efficiency measured by time, something you'll hear called time complexity, is a measure of how long it takes the algorithm to run. Stick around, we'll circle back and talk about this more. Now that you know about algorithms, complexities, and big O, let's take a break from all of that and write code in the next video. While these things are all important, as I mentioned, if you do have your video you're watching right now, you should see a Launch Workspaces button. We're going to use a treehouse coding environment called Workspaces to write all of our code. If you're familiar with using Python in a local environment, then feel free to keep doing so. Workspaces is an in-browser coding environment and will take care of all the setup and installation so you can focus on just writing and evaluating code. Workspaces is quite straightforward to use. On the left here, we have a file navigator pane. All our code, right? We'll name in here, we're going to define our linear search algorithm as a standalone function. We start with the keyword def, which defines a function or a block of code, and then we give it the name linear underscore search. This function will accept two arguments. First, the list we're searching through, and then the target value we're looking for. Both of these arguments are enclosed in a set of parentheses, and there's no space between the name of the function and the arguments. After that, we have a colon. Now, there might be a bit of confusion here. Since we already have this target value, what are we searching for? Unlike the game we played at the beginning, where John's job was to find the value, in a true implementation of linear search, we're looking for the position in the list where the value exists. If the target is in the list, then we return its position. And since this is a list, that position is going to be denoted by an index value. Now, if the target is not here, we're going to return none. The choice of what to return in the failure case may be different in other implementations of linear search. You can return -1, since that isn't typically an index value. You can also raise an exception, which is Python speak for indicating an error occurred. Now, I think for us, the most straightforward value we can return here is none. Now, let's add a comment to clarify this. So hit enter to go to the next line. And then we're going to add 3 single quotes. And then below that, on the next line, we'll say returns the position or the index position of the
I'm not
target
writing that.
if found, else returns none. And then on the next line, we'll close off those 3 quotes. This is called a docstring and is a Python convention for documenting your code. The linear search algorithm is a sequential algorithm that compares each item in the list until the target is found. To iterate or loop or walk through our list sequentially, we're going to use a for loop. Now, typically when iterating over a list in Python, we would use a loop like this. We'd say for item in list. This assigns the value at each index position to that local variable item. We don't want this though, since we primarily care about the index position. Instead, we're going to use the range function in Python to create a range of values that start at 0 and end at the number of items in the list. So we'll say for I stands for index here, in range, starting at 0 and going all the way up to the length of the list. We can get the number of items in the list using the len function. Now, going back to our talk on complexity and how individual steps in an algorithm can have its own runtimes, this is a line of code that we would have to be careful about. Python keeps track of the length of a list. So this function call here, len list, is a constant time operation. Now, if this were a naive implementation, let's say we wrote the implementation of the list, and we iterate over the list every time we call this length function, then we've already incurred a linear cost. Okay, so once we have a range of values that represent index positions in this list, we're going to iterate over that using the for loop and assign each index value to this local variable I. Using this index value, we can obtain the item at that position using subscript notation on the list. Now, this is also a constant time operation because the language says so. So we'll do if list. So once we have this value, which we'll get by using subscript notation, so we'll say list I. Once we have this value, we'll check if it matches the target. So if the value at I equals target, well, if it does, then we'll return that index value because we want the position. And once we hit this return statement, we're going to terminate our function. If the entire for loop is executed and we don't hit this return statement, then the target does not exist in the list. So at the bottom here, we'll say return none. Even though all the individual operations in our algorithm run in constant time, in the worst case scenario, this for loop here will have to go through the entire range of values and read every single element in the list, therefore giving the algorithm a big O value of n, or running in linear time. Now, if you've written code before, you've definitely written code like this a number of times, and I bet you didn't know that all along you were implementing what is essentially a well-known algorithm. So I hope this goes to show you that algorithms are a pretty approachable topic. Like everything else, this does get advanced, but as long as you take things slow, there's no reason for it to be impossible. Remember that not any block of code counts as an algorithm. To be a proper implementation of linear search, this block of code must return a value, must complete execution in a finite amount of time, and must output the same result every time for a given input set. So let's verify this with a small test. Let's write a function called verify that accepts an index value. If the value is not none, it prints the index position. If it is none, it informs us that the target was not found in the list. So def verify, and this is going to take an index value, and we'll say if index is not none, then we'll print target found at index oops, that's a colon here, index, else, that needs to go back, there we go, else we'll say target not found in list. Okay, using this function, let's define a range of numbers now. So this will be a list numbers, and we'll just go from 1 to, let's say, 10. Now, if you've written Python code before, you know that I can use a list comprehension to make this easier, but we'll keep things simple. We can now use our linear search function to search for the position of a target value in this list. So we can say result equal linear underscore search, and we're going to pass in the numbers list. That's the one we're searching through. And we want to look for the position where the value 12 exists. And then we'll verify this result. If our algorithm worked correctly, the verify function should inform us that the target did not exist. So make sure you save the file, which you can do by going up to File and Save, or hitting Command S. And then below in the terminal, you're going to type out Python linear search, or you can hit Tab and it should autocomplete, linear search.py. As you can see, correct, the target was not found in the list, so the output of our script is what we expect. For a second test, let's search for the value 6 in the list. So you can copy this, Command C to copy, and then paste it again, and we'll just change 12 here to 6. And then come back down to the terminal, hit the up arrow to execute the same command again, and hit enter.
This is pretty cool. It's pretty cool. This is pretty cool. Alright, let's do my own thing over here. I gotta charge my headphones too. I should switch to the other ones. I'm gonna switch to my other headphones real quick. So I can charge these hoes. So, I'm not sure my mic's still working. Hello, hello. Is it still working? Hello, 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 hello. Testing microphone. Alright, it should still be working. But anyway, instead of this, it'll be numbers equals. Oh no, int input. Whatever. And then result numbers. Again, this also means, yeah, let's just do 5. Yeah, this is stupid. Yeah, no, that's a flippin' stupid thing. It's not a list. I don't know why I thought that was a good idea. The
You'll notice that I forgot to hit save, so it did not account for that new change. We'll try that again. And there you'll see that if it worked correctly, which it did, the index should be number 5. Run the program on your end and make sure everything works as expected. Our algorithm returned a result in each case, it executed in a finite time, and the results were the ones we expect. In the next video, let's tackle binary search. In the last video, we left off with an implementation of linear search. Let's do the same for binary search so that we get an understanding of how this is represented in code. So we'll do this in a new file, back to File, New File, and we'll name this one.
I kind of just want to do like a butt ton of Python tutorials instead of like courses. Like I just want to maybe because if I just stick to these things, I'll only be able to get 2 of them. But if I do tutorials,
One binary.
I'll do something else. But I mean, this is a pretty cool basic search algorithm. but I would like to do Python tutorials instead of just this. I think that'd be pretty cool. I actually turned on music. Accidentally. But yeah, I think that's what I would like to do. I'm tired, you know. It'll definitely keep my interest if I just do a bunch of different stuff. Yeah, but all of these are full Python course. I don't wanna. I don't wanna. I don't wanna crash course. I don't. I just wanna a good time. Birdcage doing alright.
It's not just
Let's see
about
this.
saving time, it's about
Birdcage did a
expanding
snake game
possibilities.
Python tutorial or something like that.
Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, we're going to create a game of Snake using Python. So sit back, relax, and enjoy the show. First thing we should do is import from tkinter as well as the random module. And let's define all of the different classes and functions that we'll need. So let's create a class for our snake object as well as our food object. So for
This
the time
guy's
being, I'm just
too
going to
fast,
write path.
bro. You can slow him down a half, dude.
For my classes. We'll fill these in later. So we
Here
have
we go.
class snake and class food. And let's define all of the different functions that we'll need. So let's say we have a function named nextTurn. Change direction. Check collisions. And lastly, game over.
This dude so fast. Dude, I'm so
Okay,
sick.
for change direction, I'm going to have one parameter, a new direction. Now, when I create a game, I like to place a bunch of constants at the top of my game. Constants are variables that you do not want to change later. They're kind of like the settings. However, in Python, there are no constants compared to other programming languages. So we're just going to create a bunch of constants. So constants are values you do not want to change. left. So that is all of the constants for our game, but you can feel free to adjust if you like. Let's head down to the bottom and make our window. So we have window equals TK, and at the very end we should have window dot main loop. Let's set a title for this window. Window dot title snap game. Okay, fine, I'll spell it right. Snap game. And if you do not want your window to be resizable, you can use resizable, and then you have to pass in false twice. It's kind of strange, but it's how it is.
Not doing that.
Okay, we should have a small window, and we cannot resize this with drag. Okay, let's
Interesting.
create a score menu. Well, we probably need a score first. So let's say score equals 0 and an initial direction. Direction equals, let's say, yes. Now let's create a score table. So let's say label equals label. We're having our label over here. Let's set the text equal to score colon, then I'm going to use the format method, and we will pass in our score, whatever it is. And let's set a font, pick whatever font you
Oh, cool.
prefer. And 40 is a decent size. Then I'm going to package this label.
How do I spell label wrong, dude? I don't know why I'm getting errors. It's the exact same. Label equals label. Yeah. He's getting errors too, so.
Let's test it. Okay, we're getting somewhere. Or we
What? What is the problem here, bud? Oh, here it is. There I spelled label wrong again. Dude. Oh, I hate this kind of game. Oh, genius. Someone get me an interview at Google, please.
create a canvas. Canvas equals canvas. We're adding a filter there. I'm going to set a background color equal to our background constant.
Advertisement. Oh.
I'm going to set our height equal to the game height, and the width equal to the game width that we set. And we need to package
Perhaps I forgot a comma.
that.
Well, I'll go kill myself then.
Should animate input. I'm going to try and center this code.
Audio quality. Damn.
DQ presents How to Hit Summer's Sweet Spot. The new
What?
DQ Summer Blizzard Treat menu is here. And as the official
How's a
treat of
monster
MLB, we're
streaming?
swinging big with our fan favorite S'mores Blizzard Treat. Plus, new mixing bowl mashup with brownie batter and
How
chocolate
was
chip
that?
cookie dough. And even more in our stacked summer lineup.
The first thing we'll do is update our window so that it
DQ
renders.
Summer Blizzard Treat menu. Right now,
And then we need to find some dimensions. So let's say the window width equals
Spotify Premium lets you have
window
more control
dot
over party info,
w
ad-free listening, and offline
info
downloads. You can make every day
width
and every space a personal DJ set. Tune in
and
to Daily
window
Playlists now and cancel anytime. Tap the button
height
to learn more.
equals window dot w info height.
How well do you understand
We'll
the
need our
workflow?
screen width
Oh my
Let me
god,
tell you
bro.
an expert to myself.
I can't imagine this on
Workflow is
full
not as
speed.
mysterious than you realize. My name is Shankar Gopinath, and I host a podcast called Hidden Brain. In each episode, we explore research-based insights that will help you to better understand yourself and the people around you. Tap the banner now to listen and discover your hidden brain.
equals window dot screen width and screen height equals window dot w info screen height. Where is it? Okay, then we need to see how much we're going to adjust the position of our window. So let's say x equals screen width divided by 2 minus window width divided by 2. And same thing for y. So this will be screen height and window height. That will be y. Okay, then we need to set the dimension window dot geometry. We're going to use an X grid. So let's set the window width times window height.
Yo, I'm flipping now. How do you pay $700 for something in a building? What is going on? Why is it fucking sucks, man? Let me get my drink. back. Got me a PB&J with the bev. No bev, actually. God. I've been charging for like the last 10 minutes.
Plus
PB&J with banana. With a little bit of honey mustard. Alright, let's get back to it.
x plus y. So when we
Yeah.
pass
No. That's it.